Okay, this is the notes for 4.3, measures of regression and prediction intervals. This is a bit of a complicated unit, so it's going to have a section that's going to have a little bit more time involved. So today I'm just going to have you copy the notes. There's like three major concepts that we'll look at. One of them is total variation and its subparts. One of them is sample error, excuse me, and the other one is the error or the interval of prediction intervals. So the three types of variation about a regression line are the total variation about the regression, which is the sum of the squares of the differences between the y value of each ordered pair and the mean itself. So basically you take a y value and subtract off the mean of those y values and then square it and then add that column up, and that is your total variation. That is pretty easy to find, but you would have to do it by hand. The explained variations is the sum of the squares of the differences between the predicted value and the mean. So you pick some random predictions, x values, find their equivalent y prediction value using your regression equation you found, subtract off the mean of the original y's, and then square it, and then add up that column, and that's the explained variation. Variation is the distance from the actual point to where the line is. So we just basically are adding up all of those different distances. The explained variation is the sum of the squares of the differences between the y value of each ordered pair and each corresponding predicted. So this is the original y value and where it would be predicted. So if you took the x that was associated with that y, stuck it into your regression line, how close is it to what the real world said it should have been? Real world might have said x is 1, y is 10, but when you put it in regression, x being 1, you got a y of, say, 5. So the difference between that, 10 minus 5, would give you this number here. And then we take all of those, square them, and then add up that column. The sum of the explained and the unexplained variation is equal to the total variation. So you can find it different ways. You can find the total variation if you know what your y is and your y mean. Get that. And that is the sum of the explained and the unexplained. You can have the explained variation and the unexplained variation, add those together, and you get the total. Either way, you just want to know what is the variation. So here's some examples, and please excuse the mess over here. Make sure you pick the words that are not scratched out. So we have an equation. We know it's a regression because it has the y hat. So this is a regression equation that was found with a bunch of different numbers. We didn't have to do that part. It was already given to us. They tell us what our mean is. Our mean is 204.25 for the original y's, and here's a random point. So our x is 2. So if we put 2 in to this equation, we will get y hat for that 2. It does not necessarily mean it's 220. This is the real world number. When we put 2 in, we get y hat. So when we put y in and subtract, so we're going to do the total, which is literally just find the y, 220, minus the mean, 204.25, and that tells us the distance, the variation. So this y is 15.75 from the mean. Everything's always from the mean. So then with y hat, to get this 205.519, we had to go into a calculator, and we went 50.729 times 2 plus 104.061. And this is what you would do for y hat. Okay? And you see you get 205.519, which is where this number came from. So 205.519 minus the mean gives us 1.269. So the explained difference from that y hat is 1.269. The unexplained takes the y, original y, minus what the prediction was, 205.519, and that gives us 14.481. So what this says is that there's a variation of 15.75. there's a variation from the mean of that original y of 15.75. We can account for 1.269 of it because we predicted that amount. We can't account for the other 14. So we just say, okay, there's unexplained amount of 14.481, this distance. And that could be explained by other things, but we can't explain it mathematically. It could be something completely off the charts, like there is a road construction in the way, and that wasn't expected, and therefore we couldn't have planned for it. That would have been something. Like if you were building or remodeling a business, the expected expenses would have been explained. Things that could cause the sales to go down during a period of time, like road construction blocking the entrance to your building, is unexplained. It's not something you could have planned for. Okay, another concept that we want to talk about in this section deals with total variation and explained variation. It's called the coefficient of determination, which is r squared. And this is so easy because r squared, we find r already when we found the correlation coefficient. R squared is literally that number squared. So it's the relationship of the explained variation to the total variation. So when we find r squared, we're taking the explained and dividing out the total. But it is literally found by the coefficient is the coefficient or correlation coefficient, sorry, that should be reversed, squared. So if the correlation coefficient is r equals 0.90, the coefficient of determination is r squared or 0.90 squared or 0.81. The error, standard error of estimate, this is our second concept that you'll be doing, which again, the calculator will do all the work, but this is one concept you're going to have to do on the calculator. You cannot do it on sheets. Standard area of estimate is the standard deviation of the observed y values about the predicted. So basically, you're taking the unexplained variation, that's this top part, divided by the number of ordered pairs minus 2, which is also called the, degrees of frequency. This is n minus 2 is called the degrees of frequency. So you take the unexplained divided by the degrees of frequency and then take the square root, and you will find the standard deviation. So if you have the unexplained, it's pretty easy to do this by hand. If not, we have some calculator steps that will give us this information, and all we have to do is plug in our data. Okay, so the last concept we want to look at is the C prediction interval. Given a linear regression equation, y equals mx plus b, where y hat, and this is identifying the linear regression, and x initial, a specific variable of x, what is the C prediction? What is the range that answer could end up being? Okay, where should it land? So what should y land in? It should be between the prediction minus the error and the prediction plus the error. So there's a plus or minus scenario going on here. And here is a very crazy looking equation, which you do not have to do by hand. I figured out how to get the calculators to do it. So we just want to see it. The point of estimate is the y hat, the regression equation, and the margin of error is E. The prediction, the probability that the prediction interval contains y is C. So the ability to be inside that equation, say you wanted it a 95 probability, then that would be the area you would do. And for most of what we're going to use, 95% or 99% is going to be our two options. So just so you know, C could be 95% or 99%. Okay, so here's how we are going to do this with our calculators. These are the steps. You're going to push new document, list, and enter the list. So far, nothing special, nothing new. So we go to new document, don't remember anything. Okay, so we're going to use the data that we have used for problem number 1, our example from 4.1, which is the set of data. And you just type in your XY. Don't forget to put in your XY, that's important. And then type in your data. Okay, so I've entered my data, and then our next step is that we're going to push menu 437 and then slope. So we don't even have to change to a different screen. All you have to do is push menu 4, 3 for confidence intervals, and 7 for linear regression T intervals. That's what we're doing. So 437, make sure it says interval slope. If you click on that just to kind of see what's going on, it might have response up. We will use response later. We're only using slope right now. Okay, and then click on OK. And you're going to tell it what your X and Y was called. So my X is X, Y is Y. Leave everything else the same. Again, unless I tell you otherwise in the problem, C level should always be 0.95. The only other way it would be is 0.99. Okay, so we go to OK and we click. Now you will see a couple of pieces of information. Okay, so if you go all the way to the top, you will see the form that the regression equation was formed. A is your y-intercept, B is, in this case, is your slope. You will see C lower, C upper, and so 1.705 is the x is the slope. And if we look back at our question, we saw 1.705 as our slope. We keep going down, and we will find A, which is not 80.255, which we had on our problem. And then you will find R, which we had from a previous question from earlier, 4.1, where we were trying to find the correlation coefficient. And we find R squared, which is our correlation determination, coefficient of determination. And that is R squared is 0.825. And then we want to know what is our standard error. Okay, standard error on here is S. So standard error is S, 15.4338. And then for margin of error, we have to do a little bit of extra. We have to take our lower and our upper. Okay, so we take our upper and our lower. It's upper minus lower divided by 2. So the error amount is going to be very, very small on the scenario. So we would do control doc, pick a calculator, and you can use that var button again. So var, actually before we do that, control divide. Okay, so var upper, C upper, minus var C lower, and then over 2. And that is our margin of error. So our margin of error here was 0.064. So that is the E that we would be finding in our equation. All right, so every time we put in any Y or any X value into our regression equation, such as say we were putting in 10 just to kind of give a number, we would push, remember A is the y-intercept, B is the slope in this case, so we're going to put B times 10 plus A, which is backwards from what we're normally doing. I realize that. It's just the way that this particular version does it. And then we get 97.309. So our interval around that X value, the Y that would be for that X, is going to be 97.3091 minus 0.64 and 97.3091 plus 0.64. So our interval would be written down as 96.669 less than Y less than 97.949. So our Y that we would be expecting if X was 10 in the real world would be in between these two numbers. Okay, so that is really how we do that. And again, here is all that written out. So you would push menu 437, pick slope, put in your XY, hit OK, and then you will look for the different pieces of information you want. So something to remember, using this formula, the regression equation, is not mx plus b. They use a different one. They use b times x plus a. So that's the same thing as the mx plus b. So you just have to remember that y hat is a little bit different in this particular scenario. Okay?